help inform us as we look at this disease.
The purpose of my talk today is really to bring sort of my perspective, which is a geriatrician and health services researcher, and my work is really focused on improving quality of life for people living with Alzheimer's disease and related dementia. Bring that perspective and try and integrate it a little bit with what we're going to hear over the next 2.5 days here. And just my only disclosure is I get paid for up-to-date for being a section editor. I want to begin by putting the context of aging into a little bit of perspective, because 100 years ago, as a geriatrician, I'd be taking care of people age 45 or less. And what this slide shows is average life expectancy from what I have arbitrarily put the dawn of time, somewhere between 20 and 30-odd thousand years ago, up until 2024. And what I want to point out is that life expectancy on planet Earth stayed exactly the same, somewhere between 35, 40 years, for almost 30,000 years. And it is only in the past century that we've seen this dramatic change in human life expectancy. So that the average person in the United States can expect to live to age 78. The average person in Japan can expect to live to age 85. And when we think about, well, what is it that's driven human longevity? It's not modern medicine, folks. It's public health. If we go back to where we see the greatest changes in life expectancy, turn of the last century, that's when we figured out that separating sewage from drinking water was a really good idea. And when we do that, we double longevity. Vaccines, which come into practice in about the 1920s, 1930s, buy us another 10 to 20 years. Antibiotics, which come into, penicillin's developed in the late 30s, but doesn't really come into medical practice until the mid-50s, gets us about 5 years. And everything that we associate with modern medicine, there it is. Everything that we sort with modern medicine, 4 years or so of longevity. So for those of you who are in public health, this is where the impact has been. And not only are we living longer, but there are a lot more of us living later in life. This is what is called the squaring of the age pyramid. This is the percent of the population along here on the x-axis. This is age on the y-axis. And you can see back in 1900, there are a very, very small group of people over the age of 65. By the way, this is the baby boomers post-World War II. But as you can see, as we move up and we get to 2030, what used to be the majority of the population has become, in some ways, the minority. And in 2030, we expect something dramatic to happen, which is for the first time in all of human existence, the number of people over the age of 65 is going to eclipse the number of people under the age of 18. And there are a lot of other implications besides that. If you think about where the tax base is in most countries, that is the monies that supports our older adult population, it's down here. And as Richard pointed out, one of the downsides of living so much longer is you get to develop a disease which is specifically related to aging, which is Alzheimer's disease or a related dementia. And this is the burden of Alzheimer's disease in the United States, where right now in 2024, 1 in 9 Americans has Alzheimer's disease or a related dementia. And yet if we look at those over the age of 85, which is that dark purple, almost 1 in 3 people over the age of 85 will be diagnosed with a dementia. dementia. And as you can see, those numbers are going to increase fairly dramatically over the next 20 years. It's perhaps no wonder that the NIH, and particularly NIA, is investing so much money into this disease. And the challenge with Alzheimer's disease is that it is a disease of aging, and it is a disease that is inevitably fatal. All who develop Alzheimer's disease will either die of or die with AD. And it's a disease for which we have now almost really no effective treatment. These are the pharmacological treatments which are available in 2024. The acetylcholinesterase inhibitors, which have been around now for close to 20 years, I would guess, have a very modest reduction in cognitive decline associated with them. Memantine, which is an NMDA inhibitor, the best data that we have is it may delay nursing home placement. May. A lot of excitement about these amyloid beta targeted monoclonal antibodies. This is the amyloid hypothesis. These are directly targeted at amyloid, which is believed to be a significant contributor to Alzheimer's disease, and they are incredibly effective. When you look at PET scans of people who receive these inhibitors, amyloid goes away. You have pristine brains. Unfortunately, that's not associated with really any difference in clinical efficacy. The best that you could say is that there is minimal to modest slowing of cognitive decline with these drugs. They have some significant side effects. Brain hemorrhage is one of them. Let me repeat that. 1 in 4 will have some sort of brain edema and brain hemorrhage on these drugs. You can have headaches, they're related to falls. As I said, a tremendous amount of excitement about these drugs, and yet they have not played out. By the way, they cost about $30,000 in the United States per year for this therapy. That excludes all of the required imaging studies that go along with that, including PET scans and regular MRIs. We have multiple other medications that have been studied and yet have not been shown to be effective. And I must admit, as a practicing geriatrician, I am really pessimistic. And perhaps I shouldn't be. Is Richard still here? Yeah, Richard, maybe I shouldn't be so pessimistic, but I am really pessimistic that we are going to have a cure or an effective treatment for Alzheimer's disease in the next decade or 15 years. And particularly since I turned 60 this year, and I'm going to be sort of one in 3 and more, this means me, that I probably in my lifetime am not going to see a treatment for a disease which I'm at pretty high risk for developing because of my genetics. So if we don't have effective treatment, and if you believe my pessimism, we're not going to have one in the next little while, then maybe we should be redoubling our efforts right now at the people at risk for reducing their risk factors. And we do have some very good scientific data around what puts you at risk for Alzheimer's disease. Age, well, we can't do much about that. I would love to pick my parents, but I can't do that either, so I've inherited the wrong genes. But there are some specific established risk factors which are pretty modifiable. Education, early life, and I stole this actually from Richard's really beautiful slide that goes curly, curly, but I couldn't highlight it. There are some certainly medical and lifestyle factors that we can do a lot about. And in later life, there are also some, and the ones in sleep, and there's some emerging factors which are really interesting around sleep disorders and sleep deprivation and the risk of dementia, and indeed critical illness and being hospitalized and the risk of dementia, cumulative effects of delirium. But what I want to highlight is these ones in blue, because I think these directly relate to why we're here today, and indeed have some very interesting data and very preliminary studies that have looked at the effect of these environmental factors on the development of AD. Now, you will note that there's a big gap here. There's certainly education, and there's a really big gap in terms of anything that's related to social determinants and social deprivation. That's because Amy Kind is here, and even though I have a large ego, I wouldn't dare talk about that, which she's going to talk about that next. So, what do we know? What do we know? Well, actually, we know a lot about air pollution. And let me tell you something, air pollution is really bad for the brain. We've got data on nitrogen dioxide, fine ambient particles, both from traffic exhaust and wood, and we know that these increase the incidence of dementia, particularly in people who are genetically predisposed, those who carry the APOE4 gene. We know that there are changes associated with the, sorry folks, ever since I have COVID, one of the long-term effects of that word finding difficulties. So I can't find the word right now, so just go with me. Insert blank, related to Alzheimer's disease, related to cortical thickness, beta amyloid deposition, and cerebrospinal fluid levels of neurofilament light change. We see a greater prevalence of other abnormalities that are associated with Alzheimer's disease from pollutants, and we've been able to replicate that in the lab with mice. Particulate matter is associated with impairments of immediate recall and learning, and that may just be actually this may not be long COVID, this may be living in New York City for too many years. And some really interesting work, I think you're going to talk about this tomorrow or the next day, about how ambient air pollution or immediate changes in ambient air pollution may impact acute crisis hospitalizations for people with dementia. But there's some unanswered questions that I would pose to you. So what are the effects of timing, duration, and intensity? Are these things that we can change now, and how can we change them? I'm really interested in this idea of short-term ambient exposure, particularly for the populations that I see and the populations that I research, because these are folks who already develop dementia. And it would be really, really important for us to know how can we minimize their risk factors. And then, what's the relationship between exposure and ongoing disease progression? Can we slow it down, or does it speed up? Hearing loss. This is really, really interesting stuff. Really good data now that suggests that hearing loss is associated with development of dementia. These are data that look at people who have about a 25 decibel loss at baseline. It's almost a twofold increased risk of dementia compared to those who don't have hearing loss. And indeed, the risk of dementia increases per every 10 decibels of hearing loss. Again, structural changes in the brain related to hearing loss that we see in people with AD, and giving people a hearing aid reduces cognitive deterioration. A hearing aid is a lot cheaper than lecanemab, by the way, for a much greater effect. Some really beginning data about traffic noise. There's some low quality evidence that traffic noise may be associated with the development of AD, but the data to date are really confounded by the fact they're confounded by pollutants. That the inability to separate traffic noise from pollutant exposure, which we know is a definite risk factor. And there are some rodent models that suggest that exposure to chronic noise may increase the risk of AD. So again, what do we need to know? Well, what's the role of noise-induced hearing loss and environmental exposure on the risk of dementia? Is chronic noise an independent risk factor, or is it mediated through development of hearing loss? Just last week, my hometown paper, the New York Times, was talking about the fact that military veterans have an increased risk of AD. And the questions to that are, is that noise exposure? Is that higher rate of TBI? Is it environmental exposure to pollutants? Is it other? And it's an intriguing question, particular, in fact, my colleague, Will Hung, is speaking, I think on Wednesday, who works in the VA, and I were just talking about looking at cohorts of veterans. And then, really interesting, you know, as sleep disturbances are emerging as a risk factor for the development of AD, what is the role of chronic noise exposure in sleep disturbances? And I can tell you, again, living in New York City with windows that need to be replaced, certainly street noise exposure impairs my sleeping. And then temperature extremes. You know, we know that older adults are at significantly increased risk for heat-related events due to both their diminished perceptions of heat discomfort, impaired ability to sense thermal state, impaired thirst mechanisms, a number of other factors. And these impairments are dramatically increased in people living with dementia. You know, people with dementia may not be able to tell you that they're thirsty. They may not recognize thirst. They may not remember that they ate lunch 2 hours ago. Or more importantly, they may not remember that they forgot to eat lunch 2 hours ago. And we know that heat stress has been associated with decreased cognitive function. We now have 2 studies that have shown that people with dementia are at increased risk for death compared to others during periods of high heat. And again, this idea that 2 studies to date have found increased rates of hospitalization for people with dementia compared to others. So I think there's some really interesting work that needs to be done around climate change and its effect on people, both the risk factors for AD and for people who are actually living with that disease right now. So let me just summarize, and happy to answer questions. What do we know? Well, we know that air pollutants increase the risk of AD. I think the data on that are overwhelming and consistent. I think we need some additional studies to determine the independent and contributing effects of noise and temperature extremes, both on the risk of ADRD and outcomes for people with dementia. We've got almost no data on the association of green space and light on the risk for AD and for outcomes with people with dementia. And there are a number of very intriguing hypotheses as to what those links could be. But I have not been able to find any data, published data, in that area yet. And I would agree with Richard. I was at a meeting, I guess about a month ago, where there was this brilliant slide on Alzheimer's disease that had the biological, social, economic, genetic factors related to ADRD. There were many, many, many arrows. There were many, many, many labels. And then surrounding that was a small little circle that said exposome. And it struck me both at the time and as I was putting this talk together that there really needs to be a better integration. And that those of us who are more into the clinical and biomedical and, as Dr. Kine said, neuroscience side, need to start thinking about the exposome as integrating with the science that we're doing. And that I don't think it's reasonable anymore to say that dementia simply is a neurological or a biomedical disease. That there are a number of contexts that impact both the risk of developing this disease and its outcomes, from the biological, the individual, the organizational, policy, the exposome, and that I think that ongoing research really needs to better to integrate this, because this is the disease that we're going to be living with, not for the indefinite future. And as been pointed out earlier, has both a tremendous financial and, as importantly, clinical impact on patients and families. And thank you very much